This conference will now be recorded.
So today I wanted to just have a quick discussion on this topic that has been discussed in the past, but it's root of trust for updates. So let me share my screen. And this is kind of just me like an open-ended discussion session, I think. I only have a few slides here. So we've talked about root of trust for update as this entity which sits alongside a root of trust for measurement, but is more in charge of keeping the machine from breaking, basically. Like the root of trust for update manages updates, makes sure that the persistent storage of the various devices always have intended or not intended firm, but authentic firmware. Basically, they keep you from ending up with a JPEG or something in your flash that your device can't boot. This is closely associated with root trust for recovery. If there is something horrible in flash, how do you get out of that situation without having to send a tech out to physically repair your machine? So we've seen architectures where the machine looks something like this, where you have lots of devices. Each of them have their own RTU because they have their own distinct flash chips, and the RTU guards the flash chip. BMC has its own flash chip, and Ergo has its own RTU. So we have RTUs all over the place. They're kind of distributed here, but they don't need to be. Like we have a work stream active right now, flashless boot, where these devices can come with no flash whatsoever and can boot straight off of I3C from the BMC. So that means that really only the BMC has to boot from a flash chip, ergo would want its own RTU. So these machines of the future, they're looking like more like this, where the RTUs are centralized. Now there's a question of, do we even need an RTU at all? Can we kill it? I don't think so. Like the question here could be reframed as, is there a way to do the equivalent of flashless boot for the BMC? Like some other device outside the machine goes and boots the BMC. Maybe. I mean, that it's a possibility, right? Um, but I don't see this happening anytime soon. Completely killing all persistent boot media on the machine. As long as there must be some persistent boot media to get the machine bootstrapped, then I think we need an RTU sitting in front of that thing to make sure that it remains viable at all times.
So, Jeff, can we back up just a second? Yeah, to
Yeah.
this picture. So can we separate the concept of RTU from platform architecture, because you're mixing them a bit here, right? Like we need an RTU, and I think you just hit on the point at the end there. We need an RTU any place we have NVM that we are concerned about protecting.
Can you clarify NVM?
Non-volatile storage, non-volatile memory.
NVM. Yeah, yeah. Sorry, I heard M as in Mary, BM.
Oh,
Okay.
yeah.
Yeah.
So I mean, like whether you have NVM on the devices or not is somewhat orthogonal to RTUs and where they are and how they work, in my mind, right? Like if the device for whatever reason has storage that it needs to get working, to get itself working, then it probably needs an RTU there.
Mm-hmm.
And whether or not we can remove storage from devices for streaming boot and minimizing the amount of storage on state on platforms, that's it. To me, that's somewhat orthogonal, and I would rather not mix that with the discussion of how RTUs behave and what they do.
As in, if you have non-volatile storage, you have an RTU. If you don't have enough
Right, yeah, if
RTUs.
we back up to the previous slide, right? Maybe some of those devices have storage for whatever reason and need an RTU because maybe they don't support boot over I3C, or maybe even boot over I3C requires some bootstrapping.
Mm-hmm. Yep, I agree. I'm in full agreement with the point you're making. Um, I think the reason I kind of went in this direction was just to kind of explore, we have this trend where RTUs are being centralized, and are we going to end up in a world where we have no RTUs at all? No, because you're going to have these devices with this storage, this non-volatile memory. So like we're going to have RTUs, right? So
Yeah, well, I think if you go forward to your picture with the network, right? The question is, how do you start fetching things off the network without any local storage to bootstrap it? And
exactly,
that's
I tall
where
order.
you fail and you decide you need at least one RTU.
Yeah, exactly. So given that we are going to have RTUs for the foreseeable future, um, this begs the question: uh, what requirements do we have on the behavior of an RTU? This is kind of a stab at, if we were to enumerate the desired properties and behavior of an RTU, what would they be? Um, so anti-rollback, you want to make sure that you can't just flash uh, arbitrarily old but still validly signed images, so having some kind of ratcheting scheme. Although I'm noting here accommodating roll forward rollback practices, because oftentimes, like, you'll roll out an update and you must always be able to roll back to the one just prior. Um, so if you're not careful, you either end up in a world where you can't do that and then your automation gets sad, or you can do that, in which case all your anti-rollback is basically neutered, because you can just go, n-1, n-2, n-3 back in time. So I've got to take care of that. AB update for resilience. Make sure that there's always a working copy, even if you're interrupted in the middle of a flash. So if the old image, if the new image for some reason doesn't boot and doesn't provide some notification that, hey, I'm up, we should fall back to the old image. Ideally, once we have booted the new image, we should reconcile the A and B halves after we've been told that a successful boot has occurred. Thinking about what
One
interface. Oh, sorry. Yeah.
one question, Jeff. This must support A and B. How far do we want to go in terms of separating RTU and RT recovery?
That's a good question. If you have any more elaboration on
Well,
that.
yeah, I mean, if you have this definition of RT recovery, then you can argue that having this A and B copies and making sure that one of them is updated and that you can switch if there's a problem booting seems to be functionality of an RT recovery, right? More than an RTU. But I always wonder, do all of this, separating things in such a granular level, does that make sense? Or do we say, you know what, RTU and RT-rec are the same thing, so to speak, or the functionality, they're not the same thing, but the functionality of an RT-rec is included in an RTU, right? Which is how I see this must support A and B update.
Yeah, let's go back to this picture, right? So the RTU's role here is to keep the contents of flash valid. But if, for example, the contents of flash somehow still get corrupted, an RTU just sitting here can't do anything about it. It can't revive the device. It must be revived from out of band. So we have the BMC. And once you have that recovery path, so the BMC is basically acting as the RT-rec for that device. Once you have that path, you don't actually need the RTU, because every boot can be effectively a recovery.
No.
No?
The RT rec for the device is part of the device, right? If we're talking about a PCIe device, it has either internally or externally an RTU and an RT rec. You can draw those little boxes in there, and they're either next to each other or identical, but the BMC is not directly writing the flash, right? Usually it's going through the ASIC and some logic implemented in the ASIC. That's the recovery spec. The OCP recovery spec defines how the ASIC implements that flow so that the BMC can indirectly do the update through the device.
Right. Okay. So that in those terms, then the RT-Rec is the portion of the device which is responsible for pulling a recovery image out from external wires. Okay. So then the question is, does a device need... Now, in a flashless boot world, I think you can do away with the RTU and just have the RT-Rec, and that is your one and lone and only boot path, right?
No, you don't even have an RT-Rec then. You just have boot.
Right.
The RT-Rec flow is not the normal boot flow.
I see.
At least as defined in the recovery spec.
Okay, gotcha.
So if we go back to the other slide and we're talking about A/B update, right? It seems that there's like an implied policy here, right? How do we reconcile A and B? And why do we need A if we have recovery?
Yeah, I think that's probably the implicit assumption, is that if you have a recovery path, you don't need to be as strict about managing your A and B halves.
Right. And so what we're really saying is with A and B update, the thing that it gives you is that if B update fails, you can instantly roll back to A.
Mm-hmm.
But if your recovery path is just as fast, is there still value in keeping A?
Yeah, that's a good question.
This
Now,
this sort of boils down to the definition that whatever that NIST document was of a symbiote device, right? If the device is not needing to act on its own independently without support from other components on the platform, then it probably needs the AB updates. But if it's a PCIe device and it's always got a host that can initiate recovery, probably it can rely on that.
right. So then going back to this picture, like these devices might have RTUs, they might have RT-Rec as well for pulling stuff over a wire. The BMC, does it have an RT-Rec within it? I don't think usually it would. Where's it going to pull that off of, right? BMC is like...
Again, this is why I wanted to separate the discussion of RTU from platform architecture. If you have a PA rot, maybe your PA rot is recovering the BMC. It's how you build the platform and how you connect the components together.
Mm-hmm. So then the discussion of A and B halves is really relegated to anytime you have, as you say, non-volatile storage that needs to hold some validator to bootstrap the system. And you might have that NV storage routed through a PA rot to an RT-Rec device. Either way, or it might be the primary boot path. Either way, the contents of that NV storage is critical to stay authentic.
Hey Jeff, Prabhu here. I joined a little late. I was wondering, what does device mean in this picture?
I meant that as a placeholder for CPU, ASIC, accelerator.
Okay. So, and the RTU boxes underneath it, what do they mean?
And that's a good assumption. My assumption here is that these are typically discrete microcontrollers that have authority over some non-volatile storage.
Okay. Just to reconnect something that we did in the past conversations, we kind of put a list of devices that are kind of tabled as a proposal of critical devices from a resiliency perspective, right? This is in 2021. In the CPUs, TPUs, DPUs type of devices, they are uneven storage controllers for that matter. We kind of label them as critical devices for a data center platform. And we kind of articulated what the resiliency partitioning should look like. And for these set of devices, we basically said root of trust for detection stays with these devices, and rest of it is managed by a platform level entity, which is RTU, and RT recovery is managed by the platform. In that way, we can create a unified view of platform level orchestration that can be done on these devices. In cases where we have PCBs, it kind of becomes the same uh, concept that can be extended hierarchically, where there is a orchestration device on a subassembly, if you will.
Mm-hmm. Yeah, I think that's kind of where I was getting at with this diagram, was that you can end up with
Yeah.
hierarchy where you have one, these things boot off the BMC, BMC gets guarded by the RTU, here boots off its own flash chip. So I think what we're trending towards is anytime you have this non-volatile storage where if it gets corrupted, the platform cannot boot or recover itself, we need to, or we like to put an RTU component in front of that thing to make sure that its contents remain valid.
Yeah, and this basically kind of sets the localized recovery strategy, right, within a platform. But if you expand this concept out and say, if this particular subassembly is not functional, what is the next policy-oriented hierarchical recovery agent in that architecture of deployment?
Right, and I think in many cases, or rather, there comes a point where there's a last link in that chain, right? If your platform looks like this, not saying they all do, but if it looks like this, there is nothing you can do to recover any of it if this flash chip becomes inoperational.
Absolutely. It will have its own recovery strategy. If that fails, you are sending an SOS to someone, or whoever is bootstrapping you in the platform. They need to initiate recovery, depending on the policy.
If there's something else like wired in here that can recover it automatically over some wires, then cool. Then the RTU being here is not as critical. But if there's nothing that can reach in and fix this flash chip and boot that BMC if this is non-operational, that's I think where we're like trying to enumerate, okay, now this thing gets really critical. What must it do?
Yeah, I think the architecture can be hierarchically extended based on how SP 800-193 is laid out. If you take this as a single blade in a data center, just for conversational purposes, you will either end up dealing with a rack manager or a node manager type of intermediaries in the bootstrapping architecture for that whole enclosure, if you will, right? And they need to have their own recovery strategy for the entire platform.
Yes. Yeah.
So, so again, I think we should stop talking about platform architecture, because there are plenty of platform architectures that don't look and can't be trivialized to this, and we really should be focusing on whether the component needs to be independently recoverable or whether it can rely on an external agent to assist. Because I think those are the only two cases.
I agree, Matt.
Okay, cool. So for devices that cannot be externally recoverable, RTU is very critical. So what are the requirements we would have for that thing? That's kind of where this initial stab came from. And that's where, we were talking about AB and how critical that is, because if there's no backstop, there's nothing else that the device can do. If the flash doesn't have valid image, then we better make sure that it always has a valid image, even during flash operations. PLDM, I understand, we have there's a PLDM for firmware update, or rather firmware update over PLDM spec. So I'm just
That would
thinking of
only apply to symbiotes, though, wouldn't it?
as
Like PLDM is how you do the firmware update on the symbiote device. I don't think that helps you if you're trying to update something that needs to be autonomous.
something that needs to be autonomous. Well, so I'm like looking at a device, when it looks like this, right? So if the RTU is the only component which is allowed to write to flash, then even if nothing's wrong and the flash does have valid image, if I want to stage an update, I must go through the RTU. So I'm thinking, is there a language we can require that RTU to speak? Or
Are you assuming the RTU is an EROT, or I mean, like if I draw the picture where the RTU is just a block in the BMC, I don't think PLDM.
that makes sense. Yeah, in that case, maybe it's just a redfish thing. So yeah, I was drawing this picture and writing that list down, assuming that this was an EROT, but you're right, it doesn't have to be.
I think you probably also want to make like a duplicate of this slide for symbiote devices, just so we can distinguish between the two.
And when you say symbiote device, you're referring to like RTU within BMC?
No, I mean the things on the right.
Oh,
Something that has another agent on the platform, whether it's a PA-ROT or a BMC or the host CPU, that can help. It is not required, right? In the NIST 800 what is it, 193 terminology, it's a thing that doesn't have to do all of the detect, protect, recover on its own.
mhm. Are there elements in this list you can spot, or that you'd say like are not required for this symbiote
Well, that's what we
case?
were just saying. AB would not be required.
Right.
As long as it has a recovery. And in fact, I would say the requirements are more like you must have a recovery path and not worry about AB.
Uh-huh.
So Matt, it would be, I think it would be appropriate to state that Symbian devices are protected by chain of trust services extended by a resilient device.
They may not be.
In the architecture.
If you have, like, if we go back to slide 2, you may have storage on the symbiote device. You may need an RTU locally to protect that storage. That doesn't mean you need AB updates or autonomous behavior by the device. It may have a recovery path that can be triggered externally.
In an ideal world, um, if there is a recovery path, uh, would it make sense for us to? I mean, there is a trend and a desire to make like the boot path and the recovery path just the same, right? It's easy to test. It's not a special flow that happens only in disaster. If that, you know, takes on, or what's the word? Yeah, if that thing comes through, and you have such a path, is there a need for any RTU at all? Like, under what circumstances does it, like, in the fullness of times, what are the cases where we'd want an RTU to guard your storage and also have that remote recovery path.
If you have remote boot, you probably if you don't need local storage, then fine, then you don't need the local RTU. I think I find that future highly unlikely to exist for all devices.
Okay. Yeah. I mean,
Yeah,
we
I
have.
think that.
Sorry, go on.
Oh, Jeff. Yeah, I think the main question here is if you're a device manufacturer, what assumptions can you make about the platform provider, right? Because the Symbiont model assumes that some stuff happens in the platform and so on, right? And can you assume that all platforms where this device is going to go are going to have that functionality?
Okay.
That's hard, right?
Yeah, this flashless boot world can't really be pervasive until it's pervasive.
Right. I mean, I see the device manufacturers providing this stuff and maybe providing the option to turn it off, right, in some platforms, but not just assuming that the world is that way.
Okay.
Yes, I mean, flashless is where we want to get to, but there will be a transition time where manufacturers will need to support both. And some providers or integrators may choose the system with no flash, and then they have to have a more sophisticated BMC and mechanism for doing that.
So again, highly dependent on platform architecture, and if we draw a slightly different picture, it doesn't work at all. I don't think you're going to get away from it entirely. For some devices, certainly it'll be possible, but don't operate under the expectation that you're ever going to get away from those device-based RTUs entirely. Some devices are probably not going to be able to get rid of them.
Yeah, makes sense. It does require a bit of an ecosystem to exist with the other. I don't know what the word for other end of the Symbiont relationship is, but
A device that provides all the three services are called host devices. A device that does not have any of these services is called a Symbiont device. I kind of cut and pasted the definition from SP 800-193 in the chat.
Yeah, the other thing that I think is important to consider here is if you go into a world where things are more distributed and you have less of this concept of a chassis that has a bunch of stuff under its control, right? And then this device is going to be assigned to one group of some group of thing that makes a platform, right? One group of devices and processors and whatever, and they can be freely connected to one place or another. Then having this type of RTU in the device itself might be important, right?
Yeah, but RTU is not something we've really discussed a lot about, and it's like a critical, obviously, it's a critical component or capability from the, whether it's a device or a platform. We've talked about attestation and code integrity with secure boot, but I feel like this area has largely been neglected in terms of requirements and capabilities from a device. When we overlay it with a trap model, I know there's like system level, discussions for how the RTU comes together as a reference design or the admissible architecture thing. But like the same thing where we have the AB flash, I think was mentioned in some trap models, that's like largely insufficient. Especially in cases where there's been a key compromised and rogue firmware can run on a device and bypass the AB and just brick it. How would you get back from like a state of like bare metal recovery? Is that with a Symbiont device? how do we reason about that in a trap model? If there was a key compromise, does it brick? Does it create a scenario where a device can be remotely bricked, made unrecoverable?
I mean, I think unless you have an immutable recovery capability, right, that's always a concern, right? You can always be bricked unless you have an immutable capability.
Yeah, and that's where I thought the
Matter of,
i3C boot thing or the streaming boot was seeking to resolve that.
Yeah, so I
in
think
some
the
sense, it would
discussion,
help, yeah.
yeah, I think we've just been discussing that would be awesome, but it is going to be a very long time until device manufacturers can assume the existence of that path, because it relies on, the device manufacturer can build the capability for that, but if you don't plug it into a device with a BMC that supports that, it can't boot at all. So there's an ecosystem chicken and egg there.
I mean, how, so I don't know what the exact target of the group is, but I assume we're not targeting client devices here, right? So is it safe to assume that the types of systems that we're talking about pretty much are always going to have some sort of management controller?
I think so, but it's not I don't think we can assume for a while that all the management controllers we might want to use will support this flashless boot flow.
Understood. Yeah, that's fair.
But yeah, I think the target is it's fair to, like, if it helps to narrow the target of what we're trying to accomplish. I think keeping it to server infrastructure would, or I guess cloud infrastructure, or I don't know what it's called these days. You don't call it server because of chassis and stuff too. I don't know. Higher end devices is possibly fine unless there's lessons to be learned from client on how to do a very resilient RTO.
Yeah, it might need to be a data center thing. So we were talking about PLDM as if you're an EROT and you need to speak some language to accept an update. I picked PLDM because it exists and seems reasonable so far. But yeah, if people want to talk about that, we can. We talked about, like, if you're supporting AB update and you need to support some fallback path, like, oh, I tried to boot this device or this image, it did not boot. Let's go back to the old image. So that flow requires that the new image contact you and say, yes, I have booted. You don't have to fall back. So that that notification could be, we could spec that out in terms of PLDM. Ownership transfer is a thing that we're working through. If you're a root of trust and you want to enforce some signature over the image, and you, as a device manufacturer, want your customer to enforce their own image, their own signatures, their own signature schemes and keys, you could provide ownership transfer as an API service. Say, here's how you program your own keys. This big question mark here, we could do this, we could not, but we could say, hey, if you're gonna have an RTU, and I guess the implicit assumption is that it's an EROT, or maybe not actually, how do you even wire that up? Like, if you don't have a lot of domain experience in this, what are some well-trodden paths? We might not want to say these are all the ways you're allowed to do it, because we don't want to like impede innovation here, but just some example block diagrams, right? And again, this also assumes an AB scheme, but you can have it with two different chips with an external mux, internal mux, just translation or not between your A and B halves within a single chip. We could enumerate these and endorse them as things that have been shown to work. Anyways, that's the content I have for this sketch of a slide deck. So I guess the question to the group is, does this seem like a reasonable list of requirements? Are the ones that we don't need? We talked about, thanks for the feedback on might not need this if it is not a symbiote, or if it is a symbiote device. Clarify that. Any other thoughts on this list as it exists?
Do we include like the bottom one's a question marks, the kind of things in the works? Do we include the I3C in the works, or I keep saying I3C, streaming boot in the works as a form of RTU?
Yeah, why not? Although if you have the streaming boot, then we can just say RTU is not necessary.
I see. So yeah.
Well, it's if you don't have storage to update, you don't need an RTU.
Right.
Yeah. And the root of trust for update, does it become a I guess not necessarily. I stopped myself mid-talk. I was going to ask, does it become an aggregator for measurement, and not active measurements, but like the logs for journey? Like, does that naturally belong in, like, is there a reporting aspect to the RTU in terms of evidence on what's happened?
I'm imagining that one could have a device do both of those things, but they seem quite orthogonal. Like, if your machine looks like this, we're talking about the requirements for each of these devices, but each of these devices, I don't think you intended, we're thinking of having each of these be an aggregator for journeys. Maybe you were.
No, I was thinking of the one that kind of back here behind the BMC, or maybe the BMC itself, be like an aggregator for like changes that got, like, the update path is where it makes, like, I think it's not the only way to do this, which is kind of where I stopped myself mid-thought. It makes sense to have somewhere record events, like update events, like intentful changes to the environment, versus incidental changes to the environment. So when measurements all kind of accumulate and you can rebuild based on the logs, everything checks out good, versus when it doesn't. The source of truth for the log, where is that at in an architecture? And if a BMC was an RTU, it would seem that it's something that you may want localized, at least to the platform, but it's not necessary, so I guess it comes down to implementation.
It occurs to me that maybe these terms are wrong. I don't know, because first off, I think what you're talking about, aggregating logs and being the holder of those should really be the job of the class of a BMC, I think. Now, the RTU, when I was picturing these are like discrete components that are small, lightweight, limited SRAM. I don't think they can hold update logs for as long as the machine stays up. Then they don't need to fulfill their role as RTU, right? So a BMC could do that. Now, we call these roots of trust, right? As in, it implies a hierarchy, and these are at the root of them. Whereas these devices aren't really at the root of a hierarchy here. They are trusted components, and they manage updates. Are they roots? I don't know. Maybe we need a new term, like a update management agent. I don't know. Just there's something out there. But the thing you were describing, an aggregator point, the thing which manages the updates, right? Through which all the updates flow. It can hold onto logs. BMC can act as that component, and it can be characterized as a root in a tree, or at least a subtree like this.
Yeah. But then, to Matt's point earlier, if that device was in a different architecture, would the RTU really be an RTU in that like instantiation? Like if it was in a platform without a BMC, like the RTU, it could be device local, I guess.
I mean, I think it is a root of trust for the device. It's not a root of trust for the platform, right? And I think that goes back to what Matt, I think, was calling out earlier. You certainly have an RTU for the platform, but you can certainly also have RTUs for individual devices.
Okay, that's fine. I didn't want to get into the bike shedding of whether
It's like PA rot versus AC rot, right?
Sure. Yeah, that's fair. Okay, but still, I do think that if your platform looks like this is the component that you probably want holding onto a log if you're going to maintain that locally. But yeah, your platform might not look like this. Might say, hey, there's a BMC over there, and this is just a subordinate BMC on a tray, and all its updates come from here. Well, you could now have this thing manage those update logs, or maybe this thing still does, but it streams them off to this thing on demand.
Yeah, so I'm thinking it was probably Matt, the one who said about differentiating between RTUs and platform architecture, right? And what we're talking about when it comes down to logs and that kind of stuff, I think it's more of a platform architecture thing, right? Like, for example, some of the requirements that you would have to have if you were to provide that functionality of keeping track of what has been happening in this platform, either in the BMC or in that RTU to the left, is that those devices have to agree that they cannot or do not accept updates that are not coming through the path of the BMC, right? Most devices that I know, you can update from the host without going through the BMC, or you can update them from the BMC, right?
True.
So I think there's a whole there's a whole platform architecture that you have to fit into this, where you have restrictions like that, right? I'm going to have a log and I have to trust it, so I have to have some assurance that that device does not accept updates without the knowledge of the central place or without updating that log or something, right? But it definitely goes beyond the definition of the RTU, I think.
Yeah, agreed.
I think another thing that's not being factored in here is configuration, right? We're largely, I think, looking at this diagram from a code perspective. But I assume that each of those devices is going to have its own configuration data as well, whether streamed or whether local. I suspect most of that stuff's going to stay local for quite a while, right? I could be wrong, but again, that's another reason potentially to have an RTU at the device.
True.
Would it be possible to have the RTU as part of the flash? And maybe it's a dumb question, but there are classes of flash devices now that have microcontrollers and have the ability to do root of trust and other capabilities, secure element capabilities. I'm just curious.
I don't think that's a dumb question. I think it's, I think that's could be. I think that could easily be done. If it, imagine that it looks like this, just merge these two boxes together, right?
Yeah, like this doing secure boot validation, for example. There's nothing exposed on the bus. It's all done internally.
Yeah, I think the key thing there is some. Yeah, we do need some. I guess if it's just in part of the flash, then you program an update by just writing to it, huh?
Yeah.
So we have these other fancy things like can you fall back to the alternate half if the new half did not boot? How would that look if your interface is simply a SPI device? I'm not sure. Questions we need to answer.
Okay, thanks.
Yeah. And then
Yeah,
there's
something else. Oh, I was going to say something else that we probably want to keep in mind is complex devices like FPGAs that get the updates of the firmware from the users in some cases, right? But you probably have a lot of these requirements of RTU and so on, regardless. It's so they don't really look like these basic devices, right? When it comes to how you program the logic on an FPGA and so on. But we should probably consider what that means to this.
right. So this goes to the point of if there is a path to update it that does not flow through some central aggregator, then the prospect of maintaining logs in that aggregator is tenuous.
Yeah, or what that does that mean, right? Maybe there's a part of the responsibility that the platform has to say this is an FPGA device, right? But how that device is programmed, at what kind of firmware, or how the gates get aligned, whatever, is not part of what the platform worries about, right? It's more part of what the user or the host worries about.
I think another case you talk about logs too. We have the case where yes, the updates come through this BMC, for example, but the lifetime of the BMC can be shorter than the host. The host can stay up and alive running the firmware and have the BMC reboot in the process and stay alive.
Yeah, so then your logs are lost, or you got to run into flash to make sure they survive those kind of events. And then that could affect your flash wear leveling, depending on how often you're applying these kind of runtime updates.
And you talk about FPGAs too, another case where we just PCI adapters, if they're assigned to a virtual guest as a dedicated adapter, then that guest is allowed to do updates to that firmware. And so that would be completely outside the control of the BMC or anything else.
Yeah. Brian, do you have any thoughts on that? I know that you give a lot of thought to logs of updates.
Yeah, it's kind of the opinion it would kind of belong in like the where the update gets orchestrated from or pushed from. Like if it is PLDM, from the BMC or from somewhere centrally in the platform, like an aggregation of logs there kind of makes sense for the reasons you alluded to earlier, like the smaller RTU devices, which may be like programming a flash or pushing an image. They typically don't have the SRAM capacity for maintaining some logs. And I always think like on host based architectures, the TPM logs are typically just stored in the operating system on the host CPU. I think the industry has kind of pivoted away from like host-based architectures, and most control planes now are in a horizontal architecture that use like a combination of BMC and SmartNIC, and it's like where in these horizontal control plane architectures for cloud infrastructure, where's the best place to store um, log information? And it seems that the root of trust for update, which is the coordinator or orchestrator of updates I'm talking about at a platform level, it seems it should have visibility to um, intentional updates and be able to make recordings of like log entries based on those.
I think the concern I'm hearing from a few folks is that there are paths to several devices or several classes of devices to apply an update that do not traverse the BMC, go straight from the host. So
yeah, and I think those are becoming. I know there's probably specific architectures where those are valid, but I know at least in our environment, those aren't like those aren't we don't have like multiple. You can update it this way, you can update it that way. From this vantage point, the host CPU, the resources on that are sellable, and we like to monetize all of those sellable resources. So we don't want to have an update experience on the orchestrators from the CPU. We want it all out of band. CPU sometimes for certain updates, of course, has to be informed that there's an update about to happen. So it may need to do some quiescing, but I think for the most part, it makes sense. And there's another angle at it too. Deunificate, as we look at updates, like firmware updates from like a hierarchical like perspective, orchestrating updates from the CPU is kind of like update. You're pretty high in the stack when we look at it as layers, and to get to that point, to be able to boot this, in many cases, to be able to actually boot the CPU to a point where you can orchestrate an update is quite high in the stack, and there's a lot of things that can go wrong. You get stuck in a situation where you can't orchestrate an update, and it's like, okay, well, then you fall back to recovery. And it's like, well, why is recovery and update, why are they separate vectors? And typically what happens, when these are separate is, updates are run all the time, but recovery is run seldom. And then operationally, you grow like an atrophy in recovery, because it's just, hopefully it's a rarer event, and it's not as smooth as the update. So the unification of those two flows means that you don't grow atrophy in the recovery, and it becomes more of a seamless experience if it's aligned with the natural update. Like, kind of bundle a few things into that, but that's where my thoughts are at on it. Host-based updates for large, I think, big portion of configurations are kind of like a legacy method where you've got a very vertical stack, and I think the infrastructure management and control plane is more horizontal now than it is vertical on a CPU, which is probably something that's really different from client and other environments.
It seems almost striated a little bit. Like you do have a horizontal set of devices, right? These accelerators, CPUs, but CPUs run multiple different, like layered firmware, right? You got your UEFI, you might have some runtime services there. You have a kernel, which you can hitlessly update at any given point in time. So like the BMC is not actively involved in applying a kernel hitless update, right? It might have been the one to deliver the update to the CPU, but it's not the one actually doing the update, right?
Yep. Yeah, that's correct. Like typically, it's the same with firmware. Like typically a kernel layer on the firmware or a application layer of the firmware is actually the thing ingesting and verifying that the update, if, even today, if I write this update to Flash, I gotta check the signature on it before I do that, so I know the next time I boot, I'm not going to end up in a world of hurt. I think like with KExec and things like that, the kernel is ingesting its own updates at runtime, but where the image comes in is not necessarily a network copy over to the to an enlightened guest or a DOM0 on the kernel. It comes in horizontally now.
Sorry, when you say it comes in horizontally, you mean
via the smart NIC. Yeah.
So maybe the resolution to that is, yes, there exist these paths which don't traverse the BMC, but all the updates, well, rather, yes, there exist update paths where the immediate proximate thing doing the update doesn't go to the BMC. Like it's the host initiates it because that's how it's wired, or it's just that's the way it works, like with KExec. But maybe there's a way to wrangle it so that the BMC is still made aware of every update that comes in the door, even if it must hand it off to a subordinate component to actually do the update. Okay, well, if anyone is interested in further engagement on this particular topic of drafting up requirements for RTUs, please reach out. I may be able to have some cycles to write some more on this. But thank you all for the great discussion.
Thanks a lot, Chad.
Thanks.
Oh,
Thank
also,
you.
next week happens to be the TCG members meeting. I know there's a few people here who are active there, so we will cancel next week's iteration of this particular meeting.